Hey guys, good morning, good afternoon, good evening. Welcome once again to the SOAIR Cybersecurity Guide. We are on week 3, section 5. And what are we dealing with today? We are dealing with the introduction to vulnerabilities, the overview of the OWASP top 10 vulnerabilities. We will be dealing with understanding SQL injection and cross-site scripting, that is XSS, and we have our assignment, which is to explore vulnerable web apps using the DAM vulnerable web application, that's the DVWA. Introduction to vulnerabilities. What then are vulnerabilities? A vulnerability is a weakness, flaw, or gap in a system, application, or network, or process that could allow an attacker to gain unauthorized access or disrupt operations. Vulnerabilities compromise the security of systems by exposing them to potential threats, thereby jeopardizing the confidentiality, integrity, and availability of data and services, which is the SOAIR triad. Vulnerabilities create entry points for attacks and are one of the core concepts in cybersecurity. Importance of understanding vulnerability. It helps in risk management, helps organizations mitigate potential risks before they are exploited. It helps for compliance also. Many regulatory frameworks like the GDPR, PCI DSS, ISO 27001 requires organizations to manage and address vulnerabilities. Another importance is the proactive defense. Understanding vulnerabilities help in building a proactive cybersecurity strategy. Next is that it safeguards the SOAIR triad, which is the confidentiality, the privacy of data, integrity, the potency of data, and availability, the accessibility of data. Then again, it improves incident response by making detection and recovery quicker. Then adaptation to evolving threats. What are the types of vulnerabilities? Vulnerabilities can manifest in different forms depending on the system, environment, or behavior they exploit. Below is a detailed classification of common types of vulnerability. Firstly, we have the software vulnerability. We have the network vulnerabilities also. We have hardware vulnerability. Again, is human vulnerabilities. Next, we have the physical vulnerabilities. Then we have the IoT devices vulnerability. What is IoT device? Internet of Things. What is an example of Internet of Things? Smart home, smart office, and so on. What then is software vulnerabilities? These are weaknesses or flaws in software code that attackers can exploit to compromise its system or data. What are the examples of the software vulnerability? We have the buffer overflow, which occurs when a program writes more data to a buffer than it can handle, potentially allowing attackers to execute arbitrary codes. Next, we have the SQL injection. This is a vulnerability where attackers inject malicious SQL statements into a database query to manipulate or retrieve unauthorized data. SQL is a language in web application development. So what does this SQL injection mean? Is you injecting malware, malicious codes, malicious statements into the database to retrieve important information. Next, we have the XSS, which is the cross-site scripting, which involves injecting malicious scripts into web page viewed by other users, often to steal session cookies or data. This is very, very common on codes that were written in JavaScript. We have the cross-site request forgery, that's the CSRF, which exploits the trust. This exploits the trust a web application has in its user's browser, tricking users into performing unwanted actions. All of these are software vulnerabilities. We have the unpatched software with known vulnerabilities that haven't been fixed or updated with security patches. Next, we have the privilege escalation, exploiting vulnerabilities to gain unauthorized higher level access to resources. Next, we have the network vulnerabilities. These arise from flaws in network infrastructures or configurations. What are the examples? Open ports. Unnecessary or unsecured ports provide attackers with entry points into the system. MITM attack, which is the man-in-the-middle attack. Interception or alteration of communication between two parties, exploiting weaknesses in encryption or authentication. We have the DNS spoofing. What is DNS? Domain name service. DNS spoofing Attackers redirect traffic to malicious websites by corrupting its DNS record. We have weak encryption protocol. Use of outdated encryption methods such as WEP or weak SSL or TLP configurations. We have the misconfigured firewalls. Improperly configured firewall may expose sensitive resources to vulnerabilities. We have the hardware vulnerabilities. These are weaknesses inherent or common in physical devices or their firmware. Number one, we have the firmware exploit. Exploitations of bugs in a device firmware to gain control or access points. We have the side channel attack. Extracting sensitive data by analyzing hardware behavior such as power consumption or electromagnetic leaks. We have the meltdown and Spectre. Vulnerabilities in modern processors that allow unauthorized data access. Vulnerabilities in modern processors that allow unauthorized data access. All of these are examples of the hardware vulnerabilities. We have another one, outdated devices. Legacy hardware often lacks support for modern security updates. Now for the human vulnerability. Human behavior and human error are often exploited by attackers. Number one example is social engineering. What is social engineering? Manipulating or masquerading as illegitimate persons to retrieve or reveal confidential information. Manipulating individuals into revealing their confidential information, such as phishing or pretexting. Another one is the use of weak password. Use of easily guessable or reduced passwords are often human vulnerabilities. That's why we see some websites or some web applications will ask you to input a new password, and it will have conditions you have to meet. Firstly, it must have a special character, it must be alphanumeric, it must have figures. All of these are just a way to make your password strong and uncrackable to hackers. Next, we have the insider threat. Employees or contractors who intentionally or unintentionally compromise security. The next is lack of awareness. Users unknowingly installs malware or access malicious websites. All of these are the human vulnerability. We have physical vulnerability. Physical security weaknesses can lead to unauthorized access or damages. Unsecure premises is number one. Lack of access control measures like locks, cameras, or security personnel are a form of human or physical vulnerabilities. We have device theft. Loss or theft of laptops, mobile phones, or USB drives containing sensitive data are major vulnerabilities that we have, major physical vulnerabilities. We have the environmental factor. Lack of protection against natural disasters like flood, fires, or power surges are all examples of physical vulnerabilities. Then we have the IoT vulnerabilities, Internet of Things vulnerabilities. IoT devices often lack robust security measures, making them their easy targets. Number one, we have the default credentials. Many IoT devices use factory set credentials that are rarely changed. Number two, we have the insecure communication. Lack of encryption for data transmitted between IoT devices. Next one, we have the firmware issues. Unpatched vulnerabilities in device firmware. Next, we have the botnet formation. IoT devices are often used to create botnets for launching DDoS attack, distributed denial of service attack. The overview of OWASP top 10 vulnerabilities. What is the OWASP? Open Web Application Security Project. Top 10 is a standard awareness document for web application security. It identifies the most critical security risks to web applications by providing guidance on how to address and mitigate them. Updated periodically, the OWASP Top 10 is widely recognized and used as a baseline for web application security. What is number one? The A01:2021, which is the broken access control. What is its description? Improper implementation of security control allows unauthorized users to access restricted resources or perform actions they shouldn't. Number two is the A02:2021, which is the cryptographic failures. What is its description? Inadequate protection of sensitive data due to weak or improper cryptographic mechanisms. Next is the A03:2021, which is injection. What is its description? Malicious data sent to an interpreter causes it to execute unintended command or access unauthorized data. The next one is the A04:2021. That's insecure design. What's its description? Security issues arising from flawed designs rather than implementation. Next, we have the security misconfiguration, which is the A05:2021. What is its description? Misconfigured servers, databases, APIs, or applications that leave system vulnerable. Number 6, we have the A06:2021, which is the vulnerable and outdated component. What is its description? Use of outdated or unsupported software, libraries, or dependencies with known vulnerabilities. Number 7, we have the A07:2021, which is the identification and authentication failure. What's its description? Weak or misconfigured authentication mechanisms that allow attackers to compromise users' accounts. Number 8, we have the software and data integrity failure, which is the A08:2021. What is its description? Failure to ensure the integrity of software or data, leading to unauthorized modifications. We have number 9, which is the A09:2021, security logging and monitoring failures. What's its description? Insufficient logging and monitoring can delay detection and response to breaches or malicious activity. We have number 10, which is the A10:2021, server-side request forgery. What's its description? Vulnerabilities that allow attackers to manipulate server-side requests to access internal resources. Why is the OWASP top 10 important is the question. Number 1, for the industry standard, because it provides a baseline for securing web applications. Number two is its awareness. It helps developers and organizations recognize and address common vulnerability. Number 3 is its compliance. Many compliance frameworks like the PCI DSS references the OWASP top 10. Number 4 is the proactive defenses, which encourages secure coding and design practices from the start. Now, what does SQL injection mean? What is SQL injection? SQLI is a common and dangerous web application vulnerability that allows attackers to manipulate the queries a database receives. By injecting malicious SQL statements into an application input fields, an attacker can access or manipulate data in ways unintended by the application developer. The vulnerability occurs when user input is improperly sanitized before being included in SQL queries. Next, how does the SQL injection work? Number 1, application behavior, which means web application interacts with database or retrieves or manipulates data using SQL queries. Number 2, input fields, e.g. the login form, search bars, URL parameter, allows users to send data to the database. So their major targets are web applications that interact with database to retrieve or manipulate data, or input fields. If your website have these input fields like login form, search bars, URL parameter, it allows users to send data to their database. The next is the exploitation. Attackers inject malicious SQL code into these input fields by tricking the application into executing unintended commands. Example is the select asterisk from user, where user name equals to inverted comma user close inverted comma and password equals to pass. What is this? The first is giving a query. What's the query? Or 1 equals to 1 is the query as the username, making the query. Now the command is going to be select asterisk from user, where username equals to inverted comma user, or meeting the condition 1 equals to 1 and the password is pass. This forces the condition 1 equals to 1, which is always true, potentially granting unauthorized access. What are the types of SQL injection? We have the classic SQL injection, which directly manipulates SQL query using input fields, like adding drop table users ---- to delete database tables. Number 2, we have the blind SQL injection. The attacker cannot directly see database results but infers information through responses or behavior. What are their types? The Boolean-based blind SQL, which exploits true or false conditions to deduce information. And again, we have the time-based blind SQLer, which uses time delay like the sleep 5 to observe application responses. We have the error-based SQL, another example of SQL injection, which exploits database error messages to reveal valuable information. Example, entering malicious input to generate errors that exposes database structure. Another type of the SQL injection is the union-based SQL, which combines the results of multiple select statements into a single output to extract additional data. What are the example? Union select username, password from admin _ users --. We have number 5, which is the out of band SQL injection. This uses external channel like the DNS or HTTP request to exfiltrate data. Rarer but can be effective when other techniques are blocked. Now, another form of vulnerability is the cross-site scripting. What is cross-site scripting? XSS is a vulnerability that occurs when an application allows malicious scripts to be injected into web pages and execute in the user's browser. These scripts can steal sensitive data, impersonate users, or modify the appearance and behavior of a website. XSS attacks exploit the trust a user has in a particular website and often target client-side scripts in web application. How does this work? Number 1, by injection. An attacker injects malicious scripts, usually JavaScript, into a web application by exploiting input fields, URL parameter, or other input mechanism. Number 2, we have the execution. The web application processes and displays the malicious input without proper sanitization or validation, allowing the script to execute in the victim's browser. Impact. Once executed, the script can steal session cookies or tokens, redirect users to malicious websites, perform actions on behalf of the user without their knowledge. What are the types of XSS attack? XSS attack can be classified into 3 various types. The stored XSS, which is the persistent XSS. What is the meaning? The malicious script is permanently stored on the target server, such as in its database, common field, or user profile. Next, we have the reflected XSS, which is the non-persistent XSS. The malicious script is temporarily embedded in the response sent by the server and typically comes from users' input, e.g. a search query or URL parameter. We have the DOM-based XSS. This, the attacker occurs entirely on the client side, exploiting vulnerability in JavaScript code executed in the browser. What is the impact of the XSS attack? Firstly, compromise user data. Attackers can steal cookies, session tokens, or other sensitive information. Another one is the account takeover. By hijacking sessions, attackers can impersonate as user. Another one is the malicious redirect. Users can be redirected to phishing or malware-infected websites. Next thing is the reputation damage. An exploited website may lose users' trust and face financial and reputational consequences, and may as well lose their credibility. Next is the regulatory penalties. Organizations may face fines for non-compliance with data protection regulations like the GDPR, PCI, DSS. Thank you very much. We have come to the end of today's class. Like I said, what is our assignment? Our assignment for this week is to explore vulnerable web applications using the DVWA. And I said the DVWA is damn vulnerable web applications. Thank you very much.